Welcome to Toad Town. Mario is running a market stall, and he has a pricing dilemma. If he raises the price on a basic necessity, like a super mushroom, how many customers will he lose? And what happens if he raises the price on a luxury item, like a superstar? We know from the basic law of demand that raising prices lowers the quantity demanded, but as a business owner, Mario needs to know exactly how much the quantity will drop. To find that, we use a concept called the Price Elasticity of Demand, or PED. PED measures exactly how responsive consumers are to a change in price. The formula is simple: the percentage change in quantity demanded divided by the percentage change in price. Notice the percentage signs. We rely strictly on percentages rather than raw dollar amounts or unit numbers because it gives us a standardized measure of responsiveness regardless of how much the item originally cost. Let's run the math on the super mushroom.
Since it's a necessity for adventuring, consumers still buy it even if it costs a bit more. If Mario raises the price by 20%, the quantity demanded only drops by 10%. When we divide a negative 10% change in quantity by a positive 20% change in price, we get negative 0.5. Because price and quantity generally move in opposite directions, this calculation almost always yields a negative number. To avoid confusion, economists drop the minus sign and simply use the absolute value. So our working number is just 0.5. Anytime the PED value is less than 1, we classify that good as inelastic. This means the quantity demanded is relatively unresponsive to the change in price. This graph shows how an inelastic product behaves in the market. Looking at the top diagram, you can see that a large jump in price from P to P1 causes only a small contraction in quantity demanded from Q to Q1. The resulting demand curve is steep and rigid. You can easily remember this by picturing that steep slope forming the vertical stem of a capital letter I for inelastic. Now let's look at the superstar. It's a luxury item. If Mario increases the price by just 10%, the quantity demanded drops by 40%. Pause the video here and try to calculate the PED yourself. 40 divided by 10 gives us 4. Because this value is greater than 1, the demand for the superstar is classified as elastic. Elastic demand means consumers are highly sensitive to price changes. A small bump in price causes a massive drop in sales, as buyers decide they can easily walk away from the purchase. We can see this sensitivity on a graph as well. In this bottom diagram, a small decrease in price causes a massive extension in quantity demanded from Q to Q1, resulting in a gentle, flat demand curve. To remember this, picture the flat slope forming the horizontal crossbars of a capital letter E for elastic, representing flexible, stretchy consumer behavior. This chart places both curves on the same axes. Notice how the steep inelastic curve, marked DI, contrasts directly with the flatter elastic curve, DE. The steepness tells you immediately how flexible the buyers are. Beyond these standard goods, there are three mathematical extremes: perfectly inelastic demand with a PED, perfectly elastic demand, which stretches all the way towards infinity. You don't always need to run the math to predict a product's elasticity. We can estimate it by asking 4 key questions about its nature in the real world. Products tend to be elastic if they have many close substitutes, are considered luxuries, take up a large proportion of a buyer's income, or if the buyer has plenty of time to wait before making a purchase.
Conversely, products are usually inelastic if they are strict necessities, have few to no substitutes, cost a tiny fraction of total income, or are needed immediately by the buyer. Bringing it all together, the super mushroom is a necessity, resulting in a PED of less than 1 and a steep inelastic curve. The superstar is a luxury, yielding a PED greater than 1 and a flat, elastic curve. By mastering the price elasticity of demand, businesses can move past guesswork and mathematically predict how flexible their customers will be every time they adjust a price tag.